Hello and welcome to another one of these ADD videos. Today we're going to be talking about vector valued functions, and basically what we have here is a scenario in which we are given an equation that describes the path of a particle. In this case, this particle is going to be traveling the path of a helix. You can see that it has the parametric components of a circle in 2 dimensions, but then we throw that third t up and down, so basically the circle starts rising and it starts falling as well. So depending on what t is, you'll be giving a vector that points to a specific point on the line. Determining a specific position on this curve. Okay, so that was a t1, this would be a t2. You can even have one down here, t3. Okay, there are a bunch of equations that come along with this. You can determine what the velocity of that particle is just by taking the derivative. You can determine the acceleration by doing the second derivative. Excuse me. You can also do or find what's called a tangential vector and a normal vector. And as the name implies, it would be a vector that is tangent to the curve at a specific point. So if we were to look at, say, some other point t4, we'll make over here, we plug in some time to get this position on the path, that helical path that's described by this equation. And we know that there's going to be a vector right there that's tangential. Call that t hat. Then there's going to be another vector that's going to be perpendicular or normal. We'll call that n hat. And those two both have equations as well. Your t hat equation is going to be just the derivative of your position, in other words the velocity over the magnitude of the velocity. And if you're given a specific t value, you can then plug in after you find these things, which is the same thing as r prime of t over magnitude of r prime of t. Okay, so that was the tangential vector. I think the size might be a little too big. Let me reduce my size. The tangential, there we go, a little bit more legible. Vector. And then we move down a little bit. N hat is going to be the derivative of the t hat vector over the magnitude of that t hat, and that's the normal vector. You can also find accelerations in both of those directions. That would be the tangential acceleration in this direction, or acceleration in the normal direction as well at that given point. And again, there are multiple formulas for these things. The ones I like to use for tangential would be just taking the dot product of your acceleration that you found with your tangential vector. And then also you can do the dot product with n hat to find the acceleration in the normal direction. Alright, and finally there's something called curvature. Curvature is basically the sharpness of the turn at that given point, and also has a formula. Oops. draw straight lines apparently. Let's try that again. Somewhat better. Magnitude of the cross product of these two over the magnitude of the velocity cubed. Alright? That's curvature. So basically, one more time, we're going to have a position equation that describes the path of a moving point, and you can derive that position equation to get the velocity, take the second derivative to get the acceleration, and then we can do the velocity over the magnitude of the velocity, get the tangential vector, that's a vector tangential at any given point, and then do the derivative of said tangential vector over that magnitude to get the normal vector. And then for the curvature, or the two accelerations, I use the dot products. There are other formulas you can use. And then here for curvature, we do a cross product divided by magnitude of velocity cubed. Alright? I hope that clarified things. Be sure and watch the example videos to clarify any conception questions you might have.